Welcome to Study Loop.
So you are given a couple of equations and you're asked to solve for the unknown variables. This first equation is an application of the thin lens equation, which is 1 over s, we'll call this s1, plus 1 over s1 prime equals 1 over f. That tells us that we have a focal length of 0.1 meters, and we have a distance of the object of 100 meters. Okay, if I wanted to sketch this out, because again, this is a positive value, this does tell me it is a convex lens. Again, positive focals mean convex lenses if we're dealing with lenses. And again, this distance tells me I'm 100 meters from my lens. So this would be my focal length, and we can go ahead and measure that on both sides. Okay. So to solve for my S1 prime, I can do 1 over f minus 1 over s1, and then I can invert everything. So that becomes 1 over f minus 1 over s1. This gets us an s1 prime of about 0.1 meters. And then looking at this piece right here, this tells us that we actually have a second lens, and that 0.14 is the distance in between these two lenses. So 0.14 is the distance between these two lenses. My drawing is not to scale. So 0.14, again, we are a distance of 0.1 away, and so then we have, 0.14. So then we have a separation distance of 0.14 gets us a distance of 0.04. So that means if this is 0.1 and this is 0.14, then this distance right here would be our distance of my object. In this case, they're calling it S2. So then now that we know S2, we can use that to solve for my S2 prime, which is the image being produced by the second lens. So that actually looks very similar to our first equation. So S2 prime equals 1 over our focal minus 1 over S2. So 1 over, again, our focal for the second equation is positive. So this tells me it is a convex lens as well. And then minus 1 over that value that we calculated to be 0.04 gets me a image distance for the second lens of negative 0.84 centimeters.